All right, so we're on to 2.5, complex zeros of quadratic functions, and we're going to be using the quadratic formula. Okay, if you don't remember the quadratic formula, this would be a good time to write it down on your paper. So sing it with me. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay. So we're gonna be using that today. Got it? But we're not gonna go straight to it. We got some other stuff to do before. All right. So synonyms. Synonyms means what? What is a synonym? They're words that can be interchanged for each other, right? So synonyms that you need to be comfortable with are roots, x-intercepts, solutions, and zeros. These words are all interchangeable for each other, especially when you're solving quadratic equations, okay? So if it says, here are the roots, here are the x-intercepts, here are the solutions, here are your zeros, it's all referring to the same thing. Got it? All right. Complex zeros. So here's the blanks you need to fill in. Ready? For complex zeros, imaginary numbers / complex numbers occur when the value under the radical portion of the quadratic formula is negative. So that's our discriminant we talked about. That's that 4. I don't know why I wrote 4. I need to write b squared minus 4ac. When this is negative, so less than 0. Lately, we've been writing no real solutions, right? We're past that point now. We're going to actually write what's the imaginary solution or the complex number, the complex root. Okay. When this occurs, the equation has no x-intercepts or zeros in the set of real numbers. Okay. The roots belong to the set of complex numbers and will be called complex roots or imaginary roots. The complex roots will be expressed in the form of a plus I plus or minus bi. And the plus or minus means what? 2 solutions. You have a plus bi and you have a minus bi. Okay, so you shouldn't have much to write. Just fill it in the blanks. Still with me? Questions, comments, or concerns about the definition or usage of complex zeros?
Right.
Okay. All right. Conjugate pairs. All right. If the roots of a quadratic equation are imaginary, they always occur in a conjugate pair. Hence why we have the a plus or minus bi. Okay. So they're going to always, if I know one, then I know the other. Okay. So you know both for the fact that they are a pair. You will not have one without the other. Don't worry about writing this down. We're going to use it, but I'm showing you why. So a pair of complex numbers. So if I have a plus bi and a minus bi, when you find their product, it's going to always produce a real number in the end. Okay. Their product is going to make a real number. Okay. From here, the biggest takeaway is that I squared. So at the top of your paper, put a little asterisk, box it. But when you have I squared, it's going to equal -1. Okay, so that's going to be the needed information moving forward. Okay, equals -1. Because when you multiply a root by itself, it sets it free. All right, so let's practice conjugate pairs. So if I told you I have the complex number 2 plus 3i, what is its conjugate? 2 minus 3i. Oh my gosh. Okay, what this means is that if I was to multiply these two numbers together, I'm going to get a real number. So exhibit A. So we're going to do 2 plus 3i times 2 minus 3i. What is 2 times 2?
4.
What is 2 times -3i? What is 3i times 2? +6i. And what is 3i times -3i? That gives me -9i squared. Do we see how the multiplication worked? What happens to our middle terms? Combine and they cancel, right? So we're left with 4 minus 9. And what did we say I squared equals? -1. And a negative times a negative is a positive. So what's 4 plus 9? 13. So there's your real number that produced that complex number.
Wait, who said that I is -1? I squared.
That I squared equals -1?
Is it always?
Mhm.
So I is -1.
I equals the square root of -1. I equals the square root of -1. So therefore, I squared equals -1.
So every time I see I, square.
Every time. All right, so what's the conjugate here of 4 minus I? 4 plus I. What's the conjugate here? Right? And if I wanted to test it out, each one of these is going to produce a real number. Does that make sense? If I multiply the conjugate pairs together. That's what this little box was telling you. That when you multiply the conjugate pairs together, they're going to make a real answer. Okay? All right, how do we feel about conjugate pair?
So far.
All right, next. Now, why is this important? Well, if I am trying to find a quadratic function and you give me the complex root, I have enough information to find the function. I don't need the vertex. I don't need the intercepts. I have enough information just from this alone to find the original function, okay? So the first thing you're gonna do is write it as a factor. So I have both of my roots here. How do I know I have both of my roots? Because it says plus or minus. So we have x equals -1 plus I square root of 6. And we have x equals -1 minus I square root of 6. Those are both of my x's, right? So step 1 is you're going to write it in factored form. Okay? Factored form means that if I told you that I had a real quadratic and I said the fact I got x equals 2 is my 0, what would be the factor of that? How would I write that as a factor? X minus 2 could drop. So I'll write it as x minus 2. So I'm going to write these as factors. And just like with this, notice how what was positive became a what? Negative. So essentially, you're multiplying each one of these by -1. So my factors are going to be x plus 1 minus I square root of 6 and x plus 1 plus I square root of 6. And those are my factors. Questions about step 1 of writing in factored form? None? All right, step 2 is you're going to distribute. How you choose to distribute is up to you. You could do horizontal distribution, or you can do the box method. I'm going to tell you right now, I did not leave you enough space on your paper for either one, and I apologize. Okay, so my bad. So if you want to write small or grab another piece of paper to write it on, I apologize. I had my computer zoomed, so I thought I was leaving you enough space, but apparently.
How much do we have to do?
We have third step is to simplify. All right, so I'm going to model it with the box method. So with the box method, I'm going to end up with a 3x3 box. And the reason why it's a 3x3 box is because each one of these factors have how many terms? 3. The reason why I'm going to do the box method here is because it lets you clearly see why and when something is being canceled. Okay, so I have x +1 negative I square root of 6. I have x +1 positive I square root of 6. When you have the box, that means you're just multiplying, right? So we have x times x is x squared. X times 1 is 1x. X times negative I square root of x is negative xi square root of 6. I'm sorry. X times 1 is 1x. 1 times 1 is 1. 1 times negative I square root of 6 is negative I square root of 6. And we have xi square root of 6. We have positive I square root of 6. And we have negative I squared square root of 6. Do you see why I did it with the box though, Sam? If it helps you.
Well, I know.
Because you say you're going to try to do it in your
Oh.
head. You forgot you said that out loud? All right, so what can I eliminate from the box? Anything that has its opposite. So I have a negative xi square root of 6 and a positive xi. I have a negative I square root of 6 and a positive I square root of 6. Do you see how all of that was eliminated? And then what can I combine in the box when I simplify? I can only combine this. So the third and final step is to simplify. So when I simplify, I have x squared plus 2x plus 1 minus, what is I squared? Negative 1. And I didn't mean to write the square root. Dang it. Times 6. Because when you times the square root times itself, it does what? Sets it free. So cleaning this up, a negative times a negative is a positive. So what is positive 6 plus 1? 7. So therefore, my original function would have been f of x equals x squared plus 2x plus 7. And that's my function that came up with those, where those roots are. Huh?
So I don't know how I feel about it. Can't tell if it's easy or not.
I don't know. It's only 3 steps.
Yeah, kind of boring.
Only 3 steps.
I have fun.
Thanks, Sam. Thanks. All right, so we factored, then we wrote as factored, we distribute, we simplify, and bam, we're done. What are your questions? Questions about step 1? Writing it as a factor.
Yeah, how do you get that equation?
How do you get that equation from the box? You take everything out of the box and combine them. So I only had 1x squared, so I brought out 1x squared. Do you see that? I had 1x and 1x, which made it into 2x. I had a positive 1, and then I had negative I squared times 6. These canceled out because they're opposites. I had a positive and a negative and a positive, so they canceled each other out. Yes. I didn't mean to write the square root because when you take the square root times the square root, it sets itself free.
That's like squaring, right?
Yeah. Well, it's like pretty much, yeah. All right. Okay, so you guys are gonna do it. Okay, but I gave you only I square root of 6. So if you have positive I square root of 6, how are you gonna find your other one? Oh, you don't say. All right. Okay, I'm gonna stop talking. Let's see what you can do in 2 minutes. Get out of the park, Alden. All right.
Not real.
So I was given this complex root, so my pair is x equals negative I square root of 6. Agreed? So my factors, so we're going to write the factors, are going to be x minus I square root of 6 and x plus I square root of 6. Are we good with the factors? After the factors, we're going to distribute. How you distribute is up to you. I don't mind doing horizontal, so I'm going to do horizontal. So x times x is x squared. X times I square root of 6 is xi square root of 6. Negative I square root of 6 times x is going to be minus xi square root of 6. And then multiplying negative I square root of 6 times positive I square root of 6 is going to give me minus I squared times 6. What happens to the middle term? Cancels out. And now I'm going to simplify. So when I simplify, I'm left with x squared minus negative 1 times 6. A negative times a negative makes 8. So my original function was f of x equals x squared plus 6. How we do? Okay. Not terrible, right?
Decided to make that.
Some really boring old man sitting at home.
It's always so bad.
That's who I blame. But you also should thank them. These are devices that you're addicted to wouldn't work otherwise. Just saying. All right. Some things do for programming and coding and part of the algorithms. Yep. Here we go. Recall. Character of the solution of a quadratic equation. So the reason why this is important and why we've been doing this is because you can now fully solve your quadratic equations. You're no longer going to be accepted to write no real solution. You're going to tell me the complex solution. Does that make sense? So you're going to tell me the solution with the I. Got it? And so just remembering from our previous notes that if b squared minus 4ac is positive, we're going to have unequal real solutions. So we're going to have real solutions if this is positive. If b squared minus 4c equals 0, we're only going to have one real solution, just one. And then if b squared minus 4ac is less than 0, this is now where you're going to tell me the complex solution in its conjugate. Okay? All right, so let's do some examples. So here we have, it says find the complex roots and graph the function. So we have x squared plus 9. So for x squared plus 9 to find its complex roots, this was actually fairly easy because it's a single variable function, right? So I actually can set this equal to 0. Do I need to do the full quadratic here? No. So I'm going to subtract 9. And when I subtract 9, I'm left with x squared equals negative 9. Okay? Then I'm going to take the square root. So what are my complex roots here? X equals what? Plus or minus 3i.
Why are we adding I?
Because there's a what underneath the square root? A negative. That negative underneath the square root means that I now have to put I in my answer.
I see.
Exactly. So this is my root. These are my roots. Okay, do we see that? So x equals plus or minus 3i. Now, graphing this, we've been graphing for this past 2 sections, right? So graphing this, you just follow suit. So to graph x squared plus 9, I know that I'm going to be at positive 9. I'm going to count by 2s because I don't think I put enough on here. I don't think I put enough spaces for it to be. I don't know. Felt right in my brain. Okay. And then how would I find the vertex here? Does that change? No, I can still find my h and my k. So h equals negative b divided by 2a. And in this case, what is it? 0. Why is it 0? What?
We don't have a B.
We don't have a b. Okay. So therefore it would be 0. And so therefore my K is gonna be, you don't say 9. Oh my gosh. What? And it makes sense now why my thingy is just floating in the air. Okay. If you want to be more exact, you could try to substitute in -1. If I substitute in -1 and +1, I would be at 10, right? Does that make sense? So if I wanted to be more accurate in my graph, it would look like, I didn't even do that correctly. That does not look symmetrical at all. It was a lot of effort put into me trying to be symmetrical. Let's try that again. Okay, my pen stopped working halfway through, so we're just gonna. All right, so there's my graph, and here are my complex roots that I cannot calculate by looking at the graph. So this is an example why, even if you were to graph this using a graphing calculator, would you have your roots? Nope. You still have to be able to find them. All right. Okay, so here's your student practice. Your turn. All right, so again, this was a one variable term problem, so we could just set it equal to 0. So we subtract 16 and we're left with x squared equals -16. We took the square root, so we get x equals plus or minus 4i. There are my complex zeros. Yay. All right, so graphing. So now to graph, we need to know where our y-intercept is, because b equals 0. We know that our y-intercept and our vertex are the same. Do we see that? All right, so I'm going to go to the graph. I'm going to count by 4s. Is that cool? Yeah. We got y. I'm counting by 4s. Okay, cool. So I'm going to count by 4s. I'm going to go to 16. Okay. And if I plug in -1 here, I'm going to get 17, which is going to be roughly here and here. I want to be more accurate. You did too? Yeah, it was smart. We're going to do that too. We're going to plug 2 in and get 20. And let's see if Miss Jones can draw a better quadratic. Boom. How do you feel about doing it with a single variable term? You can do this? We're good? All right. Yeah. Woo! Okay. Now we're going to do this one. Start. Okay. We're going to find complex roots and graph the function. So you can double check yourself by asking yourself, is there anything that multiplies to give me 10 but adds to give me 6? Tell us what it is.
4 and 6, 5 and 1.
Why would you tell me to say that? No, there isn't. So therefore, we go to the quadratic formula. So that's going to be our x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? So notice how I plugged all that in. And now we're going to solve it. So we have negative 6 plus or minus the square root of 36 minus 40 all over 2. So we have negative 6 plus or minus the square root of negative 4 all over 2. What is the square root of negative 4?
2i.
2i. So now we have negative 6 plus or minus 2i over 2. Can I reduce that?
Yep.
How can I reduce that? Divide everything by 2. So 6 divided by 2 is negative 3. And 2 divided by 2 is 1. 1i. So those are my complex zeros, complex roots. How do we feel about the complex roots? It wasn't that bad following the quadratic formula, was it? Okay.
Yes, it was.
Okay, after we did that, now we're going to graph. So from here, I know my y-intercept is at 10. So we know we're going to be at 0, 10 some point. But I need to find my vertex. So to find my vertex, h equals what again? Negative b over 2a. So that gives us negative 6 over 2, which is what?
A 3.
What'd you
Sorry.
say?
I was thinking 6.
Negative 3. So I know I'm going to be at negative 3. And if I plug negative 3 in, so f of negative 3 gives me 9 minus 18 plus 10. And what is that? What'd you say?
1.
1. 1.
9 minus 18 is negative 9 plus 10 is 1.
There we go. So we're going to count by 4s. 2, 4, 6, 8, 10. I'm going to graph my vertex, and we just got that this is at 1. So I'm going to go to 3, 1. I'm going to go to 0, 10. And I can reflect that over here at 5. Someone. Where at? And there's my, hey, that's fairly decent. I'll take her. At 3, 1. I put it at positive. Dadgummit, Gina. Nope. Pretend you didn't see that over there. I wish there was a way I could move it. Let me move it. Negative 3. And again, guys, y'all just let me keep going. I don't know how I feel about this. There we go. I'll check the basket again. There we go. Sorry. All right. Thank you guys. Tomorrow we'll pick it up.